All right, guys, welcome back. This is the solving systems of equations with the use of elimination. All right, so right here on example number 4, we're going to see how a word problem pans out. So what does a word problem look like when we're dealing with systems of equations? All right, so May and Kara build computers for parts and sell them to make profit. May can build a computer in 0.8 hours, and Kara can build a computer one computer in 1 hour. Together, they worked 15 hours and built 17 computers in 1 week. How many hours did they each girl work? Did each girl work? My speech is not there today. Did they each girl work? All right, so you should know that we are dealing with systems of equations. So that means that we are creating, in this case, we're working with 2 equations, right? So we are creating 2 equations, 2 different scenarios, and these 2 different scenarios have to have the same variables, right? So if I go back and I look at this question over here, and I just look at the math, look at these 2 equations. For us to be able to answer them, we need to have the same variables. So let's go back here. Now, the secret sauce is that in every question that deals with systems of equations, there are 2 different categories all the time. There's always 2 different categories. And the 2 categories that we have in this question is, the first one is time, and the other one is number of computers. Number of computers, or just computers, right? So if you read the numbers that are associated here, we have May can build the computer in 0.8 hours and Kara can do it in 1 hour. And then they both worked 15 hours, right? So that's time. So let's go ahead and bring those numbers together, right? So starting with the easiest idea is they worked 15 hours, right? So that's both of them. So together, the amount of work, the amount of time that they worked was 15 hours. Now, how much was May? Well, May could complete it in this much, or this right here pertains to May, right? In time. Plus, how many can Kara make? I was going to say Kara, but Kara does 1 every hour, right? So 0.8 for May every hour and 1 for Kara every hour makes a total of 15 hours. So that's right. That equation right there has to do with time. Now the blue one has to do with computers, number of computers. So when we keep reading, it says they built 17 computers. That means, okay, well, together, once again, together, that's 17, that they come together and make 17 computers. But how do we find the left side of this, right? And this left side of this, even though it's super simple, it's very hidden, right? It's very hidden. The numbers are actually not given to you. Do we know how many computers May built? Nope. Do we know how many computers did Kara build? Nope. Because for us to know that, we would need to know the amount of hours they worked, right? But what we do know is that Kara and May together both, right? We need to have the same variables. They both made 17. So there you have it. We have 2 equations and they both have the same variables. They have a K and an M, right? So what do we do here? Well, we do elimination process. We can actually either graph this, do elimination, or substitution, but it just happens that we're doing elimination. So let's do elimination. Step 1 for elimination, grab your equations and line them up. Lining them up meaning that I'm going to go ahead and grab this one really quick, the one that deals with time, and just write it down. 1K is just the same thing as K, equals to 15. And then here I have, I'm not going to write the second one right now as I see it because I want to line it up. That means that my M variable, I want to put it under the M variable in this one, which looks like this. So instead of Kara plus May, it's going to say May plus Kara. Same thing. It means the same thing. So there we go. All right. So what would you do from here? Well, from here, we go ahead and say, all right, now that they're lined up, we can decide whether we're going to be adding these 2 or subtracting these 2. What is going to determine if we add them or subtract them? Where right now I can see that my K's, my 1K's are the numbers that will be able to eliminate because they're the same exact number. Do I add or subtract? The answer is subtract. 1 minus 1 becomes 0. So by subtracting these two, by subtracting these two equations, my k variables cancel out. What is that going to leave me with? Well, let's think about this for a second. What is a decimal of 0.8 minus a whole number of 1? That should give you a negative 0.2. M equals 15 minus 17. That should give us negative 2. Cool. All right, we're done with that piece. What do we do here to get m by itself? We would have to take that negative 0.2 to the other side by division. 0.2. That's going to cancel out because it's going to turn into a 1. Anything divided by itself turns into a 1. Doesn't cancel out, making 0. Understand the difference. And then here is the funniest part that trips everybody out. You got a 2 divided by a 0.2. We know a negative divided by a negative is a positive. But the funniest thing is this answer is 10. A lot of people are like, whoa, where do we get 10? We're doing, these numbers that we're working with are so small. And then usually when we divide, it turns into a smaller number. Well, when you divide by fractions, that means you're splitting it up into more pieces. Dividing is breaking stuff equally, right? Into equal amount of pieces. So let me move this over to the side. So now we have the variable m as 10. What do we do now? Well, we go back to one of our originals, which we have the options right here and right here, or just in red and blue. And we say, where do we want to plug 10 so we can get k? Well, look at this one. This one's so easy. This one's the easiest one. We know that Kara plus May, which is now 10, equals 17. Well, what does k have to be so it equals 17? That number is 7. And there you have it. And that right there is a solution of the systems of equation that we created. Now, how exactly is this supposed to be taken and interpreted, right? Well, what we found right now is we found the variables that will satisfy both of our equations. Now, all you got to do is plug them in to the blue one or the red one to determine what it is that you want to talk about. If you want to talk about how many computers they each made, just plug in those numbers, which is very simple. It's very cut and dry. K is 7, so Kara built 7 and May built 10. But if you want to figure out the time, which is the question here, the actual question here is the time. Well, same idea. Plug in your values. For M, which is right here, we would plug in 10, which will give us 8. Sorry, the answer is 8, but 0.8 times 10 is going to give us 8. 8 hours was worked by May, and then 7 times 1 is going to give us 7, which makes sense. It told us that Kara makes a computer every hour. So since she worked 7 hours, she made 7 computers, right? So this right here is our answer. May worked 8 hours and Kara worked 7 hours. Cool. All right, guys, I'm calling this the halftime. If you need to take a little short stretch break because we just finished a word problem, great. If not, let's keep moving. This next idea is solving the same thing, solving systems of equations. But right now we need to focus on what will happen if our numbers are just not cooperating with us, right? What happens when the numbers are not cooperating with us? And what do I mean? What do I mean by not cooperating? Well, if you were to solve this with the knowledge that you have by the, just the video that I've made, you would ask yourself, all right, are these lined up? Yes, the x's are lined up, the y's are lined up, and the constants are lined up. The next question is, can I add or subtract any of these so they can cancel? The answer would be no. If you add and subtract 10 and 5, they will not cancel to make 0. 5 and 3, if you add or subtract them, they will not cancel to make 0 because none of these are the same numbers or opposite numbers, like 5 and a negative 5. But what can we do? Well, hopefully you could see here by the title, by multiplication, we can make it happen. What does that mean? Well, that means that we can do anything we want in terms of multiplication to an entire equation, and it'll keep the same idea. And I'll show you in a second. This bottom equation, I could see that if I were to multiply it by 2, this 5 turns into a 10, which is exactly what I would like, right? I would like. Now, this 3 wouldn't turn into a 5, it'll turn into a 6. And if I were to say, okay, well, what if I don't multiply this equation by 2? Can I multiply something by 3 to get 5? And the answer is, you can, but it's going to be dealing with ugly fractions and decimal numbers. So right now, the easiest idea would be 2, right? Now, what does that look like? Well, we need to do the distributive property, because whatever you do to one piece of the equation, you have to do it to all of it. So that's going to give us 10x minus 6y equals negative 14. Now, a little side note, how come we are able to do that? Why did I just decide to do that out of nowhere and say, it's okay, just trust me, trust the process, just do it, and nobody's going to care? Well, check it out. I'm going to go ahead and type the original, which is 5x minus 3y equals negative 7 into decimals, and here we have it. There you go. And then I'm going to go ahead and multiply everything by 2. So it's now going to say 10x minus 6y equals negative 14. Look what happened. Same exact line. But how come these are different numbers? Well, it's just like fractions, all right? It's just like fractions. If you increase the fraction by multiplication, the top, and also the bottom by the same amount, by the same factor, then you keep the relationship of the fraction. All right, so now that we know that these two equations are essentially the same thing, then that means we can use this other one with different numbers to do the exact same thing that I wanted to do from the beginning. All I'm going to do is copy and paste the first one that we had here, which is 10x plus 5y equals 30. And I will go ahead and continue the work the same way I've done it. So I would like for you to pause right now and just look at the screen and say, wow, this is the only thing that I'm learning in this little piece of the lesson. Yes, that's it. That's it. You are just deciding of what to multiply so you can make this happen. Okay, that's it. That is the entire idea of this lesson. So what do we take from this? That means that we can now grab our two equations and decide to either add them or subtract them. Well, the answer is, since you have a positive and a positive 10, that means that our two equations want to or should subtract, so we can eliminate. 10x minus 10x eliminates to get 0. And now we have, careful warning, be careful with your minus negatives. 5y minus negative 6y. Minus negative is the equivalence of adding. So that's the same thing as saying 5y plus 6y, which would get 11y. Be careful. 30 minus negative 14. 30 minus negative 14, that's the same thing as saying 30 plus 14. So that is going to give us 44. That's it. What do we get here? Well, you're pretty much asking yourself, 11 times what gives us 44? And that is 4. Cool. All right. Now we know that we found the y value of the coordinate where these two lines intersect. What do? We go back to our original two equations and plug in the y of 4 into any of those. Which one do you want? We don't care. It doesn't matter. I'll choose the top one. 10 times x plus 5y equals 30. This is the value that we found. We know that 5 times 4 is 20. So we have 10x plus 20 equals 30. What do we do here? We would take 20 to the other side by the subtraction property of that's not a 20, of equality, to get 10 on the other side, right? So 10x, 30 minus 20 is 10. And then you ask yourself, 10 times what gives you 10? It's just 1. Bada bing, bada boom. That's our answer, people. The location where these two lines intersect is at 1, 4. 1, 4 is where these two lines intersect. All right. Make sure you can you have a decimals readily available for you if you want a visual of it. Or don't forget that you are able to grab your x and your y and plug it in here, 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 and here. And the top one should give you 30. The bottom one should give you -7. If it doesn't, something's wrong. All right. Pause this right now and check your work. All right. Here we go. Now, make sure you line them up. Your x's are lined up, y's are lined up, and your constants are lined up. The next thing in your mind would be, what are the numbers here that I can get to be the same so I can add or subtract to cancel them out? And to me, to my brain, that would be the 7 and the 14, right? That means I will go ahead and multiply the bottom by the number 2. What does that make? Well, here, here, and here, we'll get 8x plus 14y equals 2. What does this give me? 74. 3 and 3, 6, 74. Yeah. Okay, so that's the bottom one, our new bottom one. And then the top one here, the original, stays the same as a 59. Cool. All right. Now that I have these two lined up, I can go ahead and decide if I want to add these or subtract them. And the answer would be to subtract, because a 14 positive and a 14 positive will cancel if I subtract them. Cool. All right. Now, 13 minus 8 would give me 5x. And then 59 minus 74, which 59 is a smaller number, would give you a negative 15. 5 times what number will give you negative 15? Or just take 5 to the other side by division. That should give you a negative 3. And there we have it. Here's the x value for the point where these two lines intersect. Now that we have this, we can go ahead and grab any of our originals, plug it in, and see what we get for the other value. I'm going to go ahead and decide to put this on the bottom one, where we have 4 times negative 3 plus 7y equals 37. And then we have this right here becomes, okay. The 4 times negative 3 becomes negative 12 plus 7y equals 37. In this section, we take 12 to the other side by adding, right? And now what do we got? We got 7y equals 49. What number do you multiply by 7 to get 49? And that's the same exact number, which is 7. Boom. There we go. Our two lines cross, intersect at negative 3, 7. Do note, and I do understand that if you attempted to do this by plugging it into the other equation instead of this one, obviously, and you got it wrong, your answers are wrong. It is going to be tricky with checking your work and seeing where it is that you made the mistake. So these type of works are very they're not easy to always retrace your steps, because what you did is probably not what I did, or the route that you chose is probably not the route that I chose. All right. All right. So what do we have here? Listen, look at the title. Multiply both equations to eliminate a variable. All right. Now, looking at these two equations, you got the 3 and the 2, looking at the coefficients, the 3 and the negative 2, a 4 and a 3. All right. I'm focusing only on those. I don't care about the 22 and the 8 and the negative 8. So what you want to do right now is ask yourself, which of these will be easiest to get together, right, in multiplication? And the answer is actually doesn't really matter. It's whatever your brain tells you. The 3 and the 2, I can get them both to a 6, right? If you think about it, if I multiply the 3 by 2 and I multiply this negative 2 by 3, they will both turn into 6, right? So see what I did? I'm multiplying both equations to make this happen, so I can get the same number on both of them. It doesn't matter what you decide to do. Think about what I can do now here on the top. I can multiply the whole top row by 3, and notice what happens when I multiply the top here by 3. This 4 turns into a 12. And if I decide to multiply this bottom by 4, right here, it turns into a 12 as well. So this elimination will guide me to eliminate my 12s. So here's where I start to remind you once again, there are several routes that you could take, several different ways. So pick the easiest one, the one that flows with your brain. Right now, my brain is just looking at the 3 and the 2, and that's where my brain wants to go. So top one, I'm going to multiply by 3. Bottom one, I'm going to multiply by, did I just say 3? Top one, I'm going to multiply by 2. Bottom by 3. And this is what I get. So I get 6x plus 8y equals to negative 44. And then down here, I get negative 6x plus 9y equals to negative 24. Okay, cool. Now we just go exactly to everything that we know how to do. As a little reminder, this whole entire video or this section, as if you may, was literally just to teach you that you can change your equation by doing this, distributing whatever number you want to all the parts of the equation so you can get what you wanted to get. This is what we wanted to get right here, these two numbers. All right. So now that we know that our sixes are opposites in sign, you have a positive 6 and a negative 6, I am going to choose to add. Adding opposites is what cancels what cancels them out. So let me do it in a different color. Cancel, cancel. And then black. All right, so I got a plus 9 right here. That's going to get 17y. And then here I am going to get 8, 6. Oh, my Atlanta. 68. Negative 68. All right. So I got 68. I will have to take 17 to the other side by division. You're going to have to ask yourself right now, what do I multiply by 7 to get, what do I multiply by 17? Not by 7, by 17 to get 68. And that will be negative divided by positive is a negative. So we're going to stay with a negative, and it's going to be 4. Cool. All right. There we got it. I don't know about you guys, but my brain likes to use the lower one. It looks like the lower one is a little bit nicer to look at. I don't know why. So I'll go ahead and put the number that we found, which is negative 4. And here we have negative 2x. A negative 4 times a positive 3 is going to give me a negative 12. Okay, so be careful with your signs here. Here I will have to take 12 to the other side by adding. That will cancel out. That's going to leave me with negative 2x equals positive 12 and a negative 8 are going to cancel each other out. But the positives are bigger, so I'm going to have 4 left over. And then pretty much it's going to take 2 to the other side by division, giving me an x value of negative 2. Okay. So the point where these two lines cross is located at negative 2, comma, negative 4. Capiche? Capiche. All right. If you didn't know already, now you know. Go ahead and pause this right now. Try it on your own and check your work. All right. All right. All right. So check your work. Well, check your work is a silly way to put it because the answer to what we got here, let me just make sure I answered it correctly. 11x minus 6y equals 25, and then 3x plus 9y equals 60. Boom. Here you have your two lines, red and blue. They intersect at 5, 5, meaning that's the only point that both of them have in common, and that makes both equations true. Now, please don't forget that the blue line by itself has infinite amount of other points. That's what makes the line, infinite amount of points. But this one right here is the one that both of them have in common, which means that that's the only point that makes both equations true. All right. Now, here we go. This is going to be the last one that we are doing. So let's go ahead and see. I want you to take a second right now. Pause it. Pause this right now. Try to remember the little tips that I told you about about the word problem and the two different what did I say? Categories. The categories, and write your two equations based on those two different categories. All right, try it out. Go. Here is the final answer. Now, let's work to it. Let's work to it. You have two categories. All right, so if you read about it really quick, you're talking about number one is the cost, right? The actual cost. So cost. The second category would be how many he has, amount. Okay, two different categories. One talks about the cost, the amount of money. The other talks about the quantity, the amount, the number. Okay, so if we talk about the cost right now, what information here talks about cost? Well, you have these single issues that cost $4 each. And then you have paperback ones that cost $12 each because they're a little bit fancier, you know? And then it says that pretty much all these books cost them a total of 616. So there you have it. You have single use, which is $4 each. So I don't know how many he has of each. I don't know right now. But what I do know is that $4 was paid. You know, he paid $4 for each single issue. Plus, he also paid $12 for every paperback. So I'm gonna put P. So that money cost. Remember, all these numbers are still just cost. 4 for the single use, single issue. Sorry, not single use. 12 paperback. Total cost 616. Right, and then you kind of say, okay, cool. I'm done with that category. The other category is amount. What is the amount? Well, the amount of books is 100 books. Do we know how many he has from each category or each type? No, that's pretty much what we're trying to find. So, but what I do know is that his entire collection of 100 books is made up of the single issues plus paperback. I don't know which number is which. I don't know how many single issues, and I don't know how many paperbacks, but now I have 2 equations that will help me find that out. Yeah. So I got my 2 equations right here. What I want to do is I want to line them up so I can go ahead and do our elimination process. We got this. We have single issue plus paperbacks is a total of 100 books. What do we have here? Well, using elimination, I would say, can I subtract and add right now? I cannot. I am not able to subtract or add numbers right now to get 0. So what I got to do is I have to determine what equation I must multiply, either one or both of them, so I can get the numbers the same. Now, I don't know about you, but my brain tells me be simplistic. So I'm just going to multiply the bottom one by 4 so my S variables can match up, right? So distribute, distribute, distribute. And I will have here 4S plus 4P equals to 100 times 4 is 400. Copy and paste the one that we had for the first one here. 12P equals 616. Now we can go ahead and subtract or add what we have here. These 2 4s at the leading coefficients, they are positive. So if I decide to subtract my 2 equations, they will eliminate, hence the elimination method. 12 minus 4 is going to give me 8. And then I have 616 minus 400 is going to give me 216. Right? And now you pretty much ask yourself, what number do I multiply 8 by to get 216? Or just take this to the other side. Bam, bam, bam. P, or the number of paperbacks that he has based on what we have here, is 27. I didn't say 17. 27. Right? And now you know he has 27 paperbacks. Think about this part that we talked about before. He has 100 books total. So what is the other amount? Well, the single issues plus the 27 paperbacks that he already has. What number does that have to be? If you still don't see it, if your brain is kind of like, take this to the other side. And what number does that give you? That is going to give you, for the variable S, the number 73. Okay. There you have it. Now, if you plug this in your calculator, it should all make sense. 73 plus 27, does that add up to 100? It does. Now, does this also add up to the numbers that we want to add up to? The single issues, 73 of them. If you multiply that by 4, right? What does that get you? What does that get you? Do that right now. Challenge you. What is 73 multiplied by 4? What about paperback? He has 27 paperbacks. Multiply that by 12. What numbers does that give you? Now, when you add those 2 numbers, does it give you a total cost of 616? It should. If it doesn't, you got to learn how to use that calculator. So we're all done with this lesson, with this video. Stay tuned for the next one. Like and subscribe. Hit that follow button. Just kidding. Psych. Peace out.